Hi learners! In today's video, you will learn about the three trigonometric ratios, namely sine, cosine, and tangent. You will also learn how the sides of a right triangle are labeled with respect to a reference angle. The writing of the trigonometric ratios is demonstrated so that you will be able to apply these learnings in answering application problems on the topic. Strategies in analyzing and solving word problems related to the topic are showcased to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to this in the future. If your lesson is on trigonometric ratios, or if you have an assignment on this topic, or if you're preparing for a test in math or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Trigonometry is a branch of mathematics that deals with the connection between the measures of the sides and angles in a right triangle. Once an acute angle of several right triangles are the same in measure, all these right triangles having the same acute angle measures will be similar. That is certain from AA similarity. When triangles are similar, it follows that the ratios of their corresponding sides are equal. The equality of the ratios of the corresponding sides of similar right triangles led mathematicians to recognize a connection between acute angles in right triangles and the lengths of its sides. The ratio of the sides of a right triangle in relation to its acute angle are called trigonometric ratios. The acute angle in these trigonometric ratios is called the reference angle. Let's go over the important features of a right triangle. The longest side being the hypotenuse, and the other two sides its legs. On the figure, the three interior angles are angle C, the right angle, and angle A and angle B, the acute angles. Each measure of the acute angle is less than 90 degrees, but the sum of the two is 90 degrees. That is, the measure of angle A plus the measure of angle B is 90 degrees. Any of the acute angle in a right triangle can be the reference angle. Oftentimes, the name of the reference angle is taken from the name of the vertex of the acute angle. Sometimes, the symbol theta is used to represent the reference angle. For now, we will just use the names of the vertices to represent the angle's name. Now, we will relabel some sides of our right triangle so that we can start writing the trigonometric ratios. Look at the triangle, learners. Now consider yourself or an observer to be where the reference angle is. We will put an eye to represent you or an observer where the reference angle is. Let's go. When you or an observer look through angle B, the side across you is the opposite side. That is the side opposite the reference angle. Label the side as opposite side. Now the leg or side next to the reference angle is the adjacent side. Label this as adjacent side. The third side is the hypotenuse. Remember that the hypotenuse is the longest side. This is also the side opposite the right angle, so it is the side that can easily be identified if not yet labeled. Look at the labeled triangle this time, learners. With these labels, we can now write the three trigonometric ratios using angle B as the reference angle and the sides. The first is the sine of angle B, which is sine B is equal to opposite side over the hypotenuse. The second is the cosine of angle B, which is cosine B is equal to adjacent side over the hypotenuse. And the third is the tangent of angle B, which is tangent B equals opposite side over the adjacent side. Note how the labels of some side change as the reference angle is changed to angle A, the other acute angle. Across the reference angle is still the opposite side, but look at where it is now located. We will label this side. The side next to the reference angle is the adjacent side. Look at where it is now located. Again, we will label this side. Take note that the hypotenuse is still the same, for it is the longest side, also the side across the right angle. So it didn't change. For this illustration, where angle A is the reference angle, the following are the trigonometric ratios. Sine A is opposite side over the hypotenuse. Cosine A is adjacent over the hypotenuse. Tangent A is opposite side over the adjacent side. The definitions of the ratios are still the same, learners, but the positions where the opposite and the adjacent sides are now different, for the reference angle has changed. Thus, their values will now differ. Now, these trigonometric ratios may also be referred to as trigonometric functions. We can abbreviate the trigonometric ratios this way. The acronym SOHCAHTOA is oftentimes used to remember these ratios. SO stands for the sine ratio, CA stands for the cosine ratio, and TOA stands for the tangent ratio. Now, let us look at this exercise to check our understanding of the concepts. Sample problem 1. Given the triangle, which of the equations below show a trigonometric ratio for angle B? Select all that apply. A figure is given. Option A, sine B is equal to 5 over 13. Option B, cosine B is 5 over 13. Option C, cosine B is 12 over 13. Option D, tangent B is 5 over 12. Option E, tangent B is 12 over 13. And option F, sine B is 12 over 5. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? You're right, we're asked which equations show the correct trigonometric ratios for angle B. What are given? We are given a figure of a triangle with side lengths. Okay, so our strategy here is to get the trigonometric ratios for angle B using the definitions of the trigonometric ratios. The problem states that we are to get the trigonometric ratios for angle B. So angle B is our reference angle, right? We will put an arc and then position the observer's eye where angle B is. Let's go. Then, we will label the triangle and start with the hypotenuse being the easiest side to be identified. Across the eye is the opposite side. We will label it. Next to angle B is the adjacent side. We will label that too. Now, we can start determining the trigonometric ratios. We start with sine. Using the definition for sine, which is opposite over the hypotenuse, we see on our figure that the value on the opposite side is 5. The hypotenuse has 13, so sine B is 5 over 13. The next is cosine. Using the definition for cosine, which is adjacent over the hypotenuse, we need to get the value that is assigned to the adjacent side, which is 12, and the hypotenuse, which is 13. Plugging in these values, cosine B is 12 over 13. Finally, we get the tangent of angle B. Using the definition for tangent, which is opposite over the adjacent side, and plugging in the value for the opposite and adjacent sides, tangent B is 5 over 12. Now, let us check which options are correct. Is option A correct? Yes. Is option B correct? No. Is option C correct? Yes. Is option D correct? Yes. Is option E correct? No. Is option F correct? Again, no. There you are, learners. We have answered the problem. That was easy. Okay, we will move on to the next problem. Sample problem 2. Below, triangle RST is similar to triangle OPQ. Which ratio represents sine P? A figure is given. Option A, 5 over 3. Option B, 3 over 5. Option C, 5 over 4. Option D, 4 over 5. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? You're right, we're asked which ratio represents sine P. What are given? We're given that triangle RST is similar to triangle OPQ and a figure indicating that the two triangles are both right triangles, with triangle RST having side measures. Okay, so we are given that the two triangles are similar. This implies that the corresponding angles are congruent. Do you agree, learners? Next, we have to determine which angles correspond to which. Again, we can get these from the names of the triangles. The angles that correspond each other are of the same order. So, angle P corresponds to angle S, right? Now, because the right triangles are similar, the trigonometric ratios of the two triangles having the same acute angle measures are the same. Thus, sine P of the larger triangle is the same as sine S of the smaller triangle. Can you follow, learners? Since the smaller triangle has given sides, we have to get sine S of the smaller triangle first. Now, we label the triangle. We first put the eye representing the observer where the reference angle is, then we label the sides. Again, we can start by labeling first the hypotenuse, the easiest side to be identified. Now, across the reference angle where the eye is the opposite side. Label the side as opposite. Next to the reference angle is the adjacent side. We label the side as adjacent side. Now we can write the ratio for sine S. Remember that sine is opposite over the hypotenuse, so sine S is, look at the triangle, learners. Now we can plug in the values. The opposite side is 4 and the hypotenuse is 5. So sine S is 4 over 5. Since sine S is equal to sine P, then sine P is 4 over 5. So what is our answer? Correct. Option D is the answer. Again, an easy one, right? Okay, so for the next sample problem, we will first recall the following concepts about the measures of the angles inside a right triangle. In right triangle ABC, where angle C is the right angle, the triangle angle sum, which states that the sum of the angles in a triangle is 180 degrees can be written in equation form this way. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Because angle C is a right angle, which means 90 degrees, then the measure of angle A plus the measure of angle B plus 90 degrees equals 180 degrees. Subtracting 90 degrees from both sides of the equation gives us this. The measure of angle A plus the measure of angle B equals 90 degrees. Clearly, the sum of angle A and angle B is 90 degrees, which is also the measure of angle C. Can you follow, learners? From here, we can write the expression for the measure of angle A by subtracting angle B from both sides of the equation. Thus, the measure of angle A is 90 degrees minus the measure of angle B. Equivalently, the measure of angle B can be obtained by subtracting angle A from both sides of the equation. Thus, the measure of angle B equals 90 degrees minus the measure of angle A. We have to remember this, learners, for we will apply these learnings in our next sample problem. Okay, so here is sample problem 3. Below is right triangle MNO. Which of the listed value is equal to cosine M? A figure is given. Option A, R over T. Option B, S over R. Option C, S over T. Option D, cosine of angle O. Option E, sine of angle O. Option F, cosine of 90 degrees minus the measure of angle O. Option D, cosine of 90 degrees minus the measure of angle M. Option H, sine of 90 degrees minus the measure of angle O. And option I, sine of 90 degrees minus the measure of angle M. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? You're right. We're asked to identify which of the listed values are equal to cosine of angle M. What are given? We're given a figure with right triangle MNO with values for its side lengths. We will examine the figure and mark the reference angle by putting the observer's eye on it. Let's go. Now, we can label the sides. With the labeled triangle, we can now get cosine of angle M. We start with the definition of cosine, which is adjacent over the hypotenuse. So cosine of M is adjacent over the hypotenuse. Look at the drawing. The adjacent side is labeled S and the hypotenuse is labeled T. So plugging in the values, we have cosine of angle M is equal to S over T. Now, because cosine of angle M is S over T, then R over T or S over R are surely not correct, for they define another trigonometric ratios. Let us look at our options. Which one is the correct one? And which ones can we eliminate this early? Okay, so option C is correct. This early, we can eliminate options A and B. Next, we will check the trigonometric ratios for angle O, the other acute angle. With angle O as the reference angle, we will move the observer's eye to angle O. With that, we can now label the triangle this way. Look at the drawing, learners. With the definition of sine, which is opposite over the hypotenuse, where the opposite side has a value of S and the hypotenuse having a value of T, sine O is S over T. Remember that earlier we got this. Cosine M is equal to S over T. Now we have sine O is equal to S over T. What does it imply? You are correct. It implies that cosine of angle M is equal to sine of angle O, since both are equal to S over T. So, since S over T is sine of angle O, then S over T can no longer be the cosine of angle O or tangent of angle O. Can you follow, learners? Okay, let us look at our options and check if sine of angle O is in our option. Let's go. Okay, so option D is correct. As what we said, it can no longer be cosine of angle O or tangent of angle O. So option D is not correct. We can also eliminate option D. The remaining options have expressions of 90 degrees minus an angle. We will investigate if there are still correct answers on the remaining options that are here. Now take note that the measure of angle M plus the measure of angle O equals 90 degrees. From here, the measure of angle M is equal to 90 degrees minus the measure of angle O. Or simply, M is equal to 90 minus O. So, cosine of M is equal to the cosine of 90 degrees minus the measure of angle O. Earlier, we got the value of cosine of M. Cosine of angle M is equal to S over T, which happens to be correct. Therefore, the cosine of 90 degrees minus the measure of angle O is equal to S over T. So, cosine of 90 degrees minus the measure of angle O is correct. That means that any other trigonometric function having 90 degrees minus the measure of angle O as its reference angle is not correct. Let us look at our options and check if cosine of 90 degrees minus the measure of angle O is there. Let's go. So option F is correct. With this, option H, which is the sine of 90 degrees minus the measure of angle O, is not correct. In like manner, the measure of angle O is equal to 90 degrees minus the measure of angle M. Or simply, O is equal to 90 degrees minus M. So, sine of angle O is equal to the sine of 90 degrees minus the measure of angle M. Earlier, we found that the sine of angle O is S over T, which is a correct answer. Therefore, sine of 90 degrees minus the measure of angle M is equal to S over T. So, sine of 90 degrees minus the measure of angle M is correct. That means that any other trigonometric function having 90 degrees minus the measure of angle M as its reference angle is not correct. Let us look at our options and check if sine of 90 degrees minus the measure of angle M is there. Let's go. There you are, learners. Option I is also correct. With this, option G is definitely wrong. So what are our answers? There you are, learners. Our answers are option C, option E, option F, and option I. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned in today's video. We have learned that, first, trigonometry is a branch of mathematics that deals with the connection between the measures of the sides and the angles in a right triangle. Second, the ratios of the sides of a right triangle in relation to its acute angle are called trigonometric ratios. Third, the following are the trigonometric ratios of triangle ABC with angle B as its reference angle. Sine B is opposite over the hypotenuse. Cosine B is adjacent over the hypotenuse. Tangent B is opposite over the adjacent side. A figure is given where angle B is the reference angle. Fourth, the following is oftentimes used to remember these ratios. SOHCAHTOA, where SO is for the sine ratio, CA is for the cosine ratio, and TOA is for the tangent ratio. Fifth, In triangle ABC, where angle C is a right angle, the triangle angle sum, which states that the sum of the angles in a triangle is 180 degrees, which is written in equation form this way: the measure of angle A plus the measure of angle B plus 90 degrees equals 180 degrees, indicates that the measure of angle A plus the measure of angle B is 90 degrees. Equivalently, the measure of angle B is equal to 90 degrees minus the measure of angle A, and the measure of angle A is equal to 90 degrees minus the measure of angle B. Sixth, when solving a problem, you must read it and may read it several times when needed to know what you are looking for, to determine what are given, and to figure out how the given information help find what you're looking for. Seventh, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.